Hi class, so today we are going to be working on multi-step equations, which includes variables on both sides. Not equations, sorry, inequalities. Okay, so we're just taking that step further of what do we do when there's multiple steps with inequalities. So we broke down multi-step and variable on both sides with equations, but we're not going to do that with inequalities. And remember, we said that while there were some specific suggestions or guidelines I was going to give you in terms of what order you might consider solving, this is not a requirement. So you don't have to do everything in exactly this step, but this is typically the way that students tend to go. So the first thing that we tend to do is if we see parentheses, we distribute. Okay, the second thing that we tend to do is if there are like terms on one side of the inequality sign, we are going to combine like terms. Okay, the next step that we tend to do is that if there are variables on both sides of the inequality sign, we are going to get the variables on one side together. Okay, we said if we had a large fraction, right, that was sort of my made up thing of a large fraction, that we would deal with it by isolating it, getting it by itself, and then multiplying by the denominator. Right, we've talked about that in class, that large fraction really has parentheses on the top, even though we don't see it. And then once we dealt with that, then we were down to something that we could solve by undoing addition and subtraction, and then undoing multiplication and division. Okay, and even in class, we've looked at the fact that we could really undo those in different orders as long as we're really following the rules super well. But, okay, in general, this is sort of the steps we go through. So let's say we are looking at 6 times 2x plus 4 minus 7x is greater than or equal to 84. And just as a reminder, we said that we will solve inequalities with those exact same steps as equations with two things we're keeping in the back of our mind. If we have to rewrite it with the variable first, that's a reason to flip the inequality sign. And if we are ever multiplying or dividing by a negative to solve, we have to flip the inequality sign. So we want to keep those things in our mind as we're going through. Okay, so when we go down our list here, right, do we need to distribute? And the answer on this one is yes, so we're going to distribute. We distribute through multiplication, so 6 times 2 is 12, 6 times 4 is 24, so we'll get 12x plus 24, minus 7x is greater than or equal to 84. Then we're going to combine like terms if they are on the same side, which we have like terms. So 12x minus 7x, right, we use that sign in front of it, gives a 5x plus 24. On this problem, we do not have variables on both sides, so we don't have to worry about that. We do not have a large fraction, so no problem there. So now we're just down to solving with our two-step equation rules. Subtracting is never a reason to flip the sign. Okay, we're dividing, but here we're dividing by a positive, so the inequality symbol stays the same. Okay, let's take a look at another one. 5x plus 22 is less than 9x minus 8. Okay, so if we sort of go through our guidelines, there's no parentheses, so we don't have to distribute. We do not have like terms to combine on one side, right? Nothing we can combine over here or that we can combine over here. So we move on to step 3 that says, do we have variables on opposite sides to get together? Which we do. So we tend to prefer to move the smaller one, but again, remember, you could move either. Okay, so this is a positive 5x. I'm going to use a negative 5x. I'm always writing it underneath the x. Okay, no large fraction, so now I'm just down to solving a two-step, right? I'm undoing subtraction with addition. I'm undoing multiplication with division. I'm dividing by a positive, so that's not a reason to flip the sign. This does not divide evenly, so decimal, mixed number, reduced, whatever, 15 over 2, 7.5. Okay, and then we do want our answers with the variable first with inequalities. So if we rewrite this, that is a reason to flip the inequality sign, right? So x is greater than 15 over 2, x is greater than 7.5, x is greater than 7.5. Any of those options would be fine. So let's another one. What if we have 17 is less than or equal to negative 3 times x plus 5 all over negative 2. Okay, so if we look at this problem, the first thing we're saying is, are there parentheses? And the answer to that question is yes, so we want to distribute. Now here we have to be careful because we are multiplying by a negative, right? I'm distributing a negative 3. However, I'm not multiplying by a negative to solve. I'm multiplying by a negative to simplify, right? I'm trying to get rid of those parentheses, which is simplifying. Nothing is getting moved to the other side of the inequality, so that is not a reason to flip the inequality sign. Okay, I don't have any like terms on the same side or both sides, but I do have a large fraction. So large fraction means move that denominator. So I'm going to undo dividing by negative 2 by multiplying by negative 2. Multiplying by negative 2 is a reason to flip the sign. So now I have negative 34 is greater than or equal to negative 3x minus 15. Okay, we'll undo our subtraction with addition. Adding is never a reason to flip the sign. Adding or subtracting, no matter what the numbers are, is never a reason to flip the sign. So we're going to add 15, and we'll get negative 19 is greater than or equal to negative 3x. We are then going to undo multiplication with division. We are dividing by a negative, so again, that's a reason to flip the sign. So I'm just going to leave this as a fraction, but 2 negatives make a positive. I'm going to flip my inequality sign. And now I want my final answer to have the variable first. So that is another reason to flip the sign. Now again, you could leave this as 19/3 because that's reduced. You could also do this as 6 1/3. I guess you could do 6.3 if you had the repeating bar. You would have to have that repeating bar. Okay, one more example I want to look at. Times x minus 8 is greater than a 3x minus 11 plus x minus 21. So again, if we see parentheses, we want to distribute. So that's the first thing we're going to do. So when we distribute, we'll get a 4x minus 32. Now, I'm totally fine with you realizing you can also combine like terms and doing that in the same step. There's no problem there. So a 3x plus a 1x gives us a 4x. And then we have a negative 11 and a negative 21, or negative 11 minus 21. Which gives us a negative 32. We have variables on opposite sides, so we need to get those together with the opposite sign. Remember, 4x minus 4x just cancels. It goes away. There is no variable left. Those both cancel out. Now, we have to be careful because we now have an inequality sign instead of an equal sign. However, the process is still the same. So we're deciding if it's true or if it's false, right? And the rules are the same. If we get a false statement, we're going to say no solution. And if we get a true statement, we're going to say all solutions are all real numbers. Okay, so if we look at this, is negative 32 greater than negative 32? And the answer to that is no, it's not, right? It would be greater than or equal to if we had the or equal to sign, but that is not there. So this is a false statement, and our answer on this one would be a no solution.